Hey, we'll go ahead and get started. My name is Craig, and welcome. Hopefully, as Nick said, you're here for traditional ML at scale. Every year, we do since GenAI launched, every year we require ourselves to do at least one ML talk. And so welcome. Was anyone at last year's ML talk? Uh-oh. Well, you might see some stuff you've seen before, but just ignore that. No, there's actually some really cool changes coming that we'll get to show you as well. Forward-looking statement, don't trade stock or whatever on anything I'm about to say, and know that anything I'm about to say that is forward-looking may or may not be true. So just know that. All right. Myself, Craig, Nick will be joining me as well on stage shortly. But my name's Craig. I run product management for AI and ML here at Databricks. Previous to Databricks, I was at Google where I built Vertex AI, and then previous to that, I was the founder of SageMaker at Amazon. And my objective has been trying to help people and organizations make better decisions with data, right? And so before we get started, when somebody tells you your baby is pretty, you make everybody look at pictures of your baby, and this is kind of like the equivalent if you're me, right? And so, yes, we were just named the leader in Gartner's Magic Quadrant for multiple years in a row, but the key this year was that we are the leader of leaders. We are higher up on the ability to execute and further over on vision than any other player. And I know you have to squint and really zoom in, but we do beat AWS by a pixel or two on the execution. And really, beating AWS on execution is always that is never an easy task. But super excited. Last year we were the highest on I guess I can show you this. Last year we were the highest on execution, but we were being beat by Google, Microsoft, and Dataiku on vision. And I think that a lot of if you were at the keynote this morning and you saw agent bricks and kind of some of these types of innovations around evaluation and around really trying to bridge that gap between the simplicity with which we've all wanted GenAI to be built and the accuracy that we need in order to deploy these things in actual real situations, not just kind of cool little toys for my friends and I. Crossing that bridge and connecting those things, I think, is a lot of what drove the improvement in vision over this past year. But so we're here to talk about machine learning, not AI. I'm proud of you. You are swimming upstream here in 2025. But listen, there's probably more money will be made in 2025 on machine learning in businesses than will on GenAI. Right? More money will be spent on GenAI, but far more money will be made because of things like forecasts and well-tuned XGBoost models and what have you, right? But so why ML on Databricks? When I was at Google, when we built Vertex AI, we actually built it with MLOps at the center of it. The goal was to try and reduce cycle time. And I remember sitting down, we had a meeting with a customer, and the customer said, we're like, I love this. The MLOps is great. You've taken my cycle time from 3 weeks to 3 days. And we all kind of high-fived. We were like, yeah, that's the idea. It's great. And he leaned across the table, kind of smirked, and said, next year I'll be back, and I want it to be 3 hours. Right? I laughed in his face. I looked at him, and I just started laughing. And I tried to explain to him. I was like, listen, I hear you, but this was a once in the development of this technology moment where we took computer science best practices, we applied it to data science, and we got this acceleration. You don't get this again next year. And he kind of nodded as if he had heard me and then smiled again and said, yeah, I'll be back, and I want it to be 3 hours all the same. That afternoon, I had a pandemic beer with over video conference with the most senior engineer on AI at Google Cloud. And we sat down and we were chatting about, hey, how would we go get that next order of magnitude of cycle time? And for the first half of our discussion, we really just felt sorry for ourselves. And we're like, this guy is not realistic. We basically just said all the reasons why this guy was not was someone we didn't have to listen to. But ultimately, by the end of the conversation, we really thought we had figured it out. we really thought that if you could join the AI system and the data system into one system, not two systems that connect through kind of, thin APIs, but if you could actually make them one system, you might be able to start building towards another order of magnitude change. There are two companies in the world who do this. One is SAS out of North Carolina, the statistical software guys, right? They have a AI system and a data system that are one system. And the other one is Databricks, right? It was about 6 weeks after that conversation that I started at Databricks, knowing that if I came to Databricks and worked on ML here, we'd be able to change the conversation in the industry. And if you look at the way that AWS is reacting with things like S3 tables, or Fabric is trying to react with its connections to Foundry, and you start looking across the industry, and you're seeing some of the influence that Databricks is having of having this unified platform. Now, the challenge is, how do we differentiate? Well, in many ways, it's this unified platform that differentiates us. It's the fact that if you have a really strong catalog, you actually don't need a feature store, because your feature store can be your catalog, and vice versa, right? Having a second catalog that is your feature store that's just special data for the data scientists that we don't really know how it's connected to the data the rest of the company is using, and the data scientists, they always measure our revenue differently than the analysts do, and all these kinds of things. That just goes away if it's one system, right? And so the challenge with this is that this is unbelievably hard to do unless you start at the beginning. Retrofitting the kind of unification that's needed at the most foundational levels it's one of the reasons we see challenges with products like Fabric and others that try and kind of do this post hoc, is they really struggle to be able to fully unify these systems. And so apologies in advance. We're going to talk about some really cool, exciting machine learning stuff, but we're also going to talk about some boring stuff. Because what you find out after a little while is that things like lineage and governance and monitoring and the ability to understand, hey, this model, where did it come from? Why do we have it? What is it? What data is it using? All of these kinds of concepts end up being often as important as the most recent hyperparameter you tuned for your model, right? And often more important, maybe, than that final hyperparameter you tuned, kind of thing. And so this idea of bringing these things together, we're going to talk about some boring stuff. We will stay till the end, by the way, because there is some exciting stuff. We just put it all at the end. So you'll sit through this with us. But to dive in, so what are we going to talk about? Well, we're going to start by talking about, hey, exploring your data, lakehouse features, right? And kind of what that means, right? Feature pipelines and how we help you with those feature pipelines, training and understanding your model, registering and governing your model, and then ultimately reducing complexity and increasing your compliance and your transparency. There's a reason, and hopefully at the end of this you'll all be able to kind of talk through this reason, but there's a reason why Databricks over-indexes with banks and hospitals. Right? And we over-index with banks and hospitals because they live in a highly compliant world, and they need to know, hey, this model, where did it come from? How do we know we can trust it? How do we know that it's good, right? And that's a lot of what we're going to try. That's a lot of what we try and help organizations with. So it starts in ML. It always starts with the data, right? And the ability to explore and understand that data. And we've seen a lot of changes recently. Now we have things like text to dashboard or text to SQL in AI BI. But we also have award-winning notebooks that allow you kind of really what is a very state-of-the-art ability to go and explore your data at the most granular levels and kind of roll that up to really understand what exactly it is you're going after here. Now, the best feature store is your data catalog. As I said, we are adamant at Databricks about the fact that you should have one copy of your data. And once you start copying that data into other stores and other data silos, we eventually end up with those data sources diverging from each other. And once that starts to happen, we wonder whether or not we're building the thing we thought we built, right? Simplifying ML features overall, right? How do we find and declare them, right? How can we help organizations really reduce? I remember when we were building SageMaker, we were talking to teams within Amazon about whether or not they would use us. And I went and talked to the fraud team, and the fraud team said, this was before Michelangelo and kind of early in that, they said, we have this place where we collect all of our features. They didn't use the word feature store because they didn't have that word at the time. But they said, the challenge for us is that anytime we want a new data field in our models, it takes 4 to 6 weeks for our engineers to put it together, right? And the ability, if I think to myself the number of times I've built a model where I've experimented with different features throughout the build, if I had to wait 4 to 6 weeks for each one of those, it would have been impossible. Certainly the guy whose cycle time wants to go to 3 hours would have been dead in the water, right? And so this is the capability of, listen, any table you have that has a primary key can be any of those columns can now just be features, right? Tag them as features, we'll talk a little bit about pipelines. Now, one of the benefits of having a system that is your data and your AI system is that you no longer deal with this classic problem of, hang on. There we go. One of these classic problems, maybe you've seen this before, but I was talking to a company just Tuesday, about machine learning, and they said one of the challenges they have is they train a model. Their data scientists train a model, they tell everybody about it, they write up the report about it, they're ready to put it in production, and they give it to the ML engineers. The ML engineers look at it and say, hey, these features that you pulled out of the data warehouse, we have no idea where these features are in prod. We have no idea how to serve this model, right? But Databricks lineage gives you the ability to immediately look at that data warehouse table and trace the lineage back to whatever the ingestion point was so that you can figure out that relationship, right? But not only that, it also will go build the pipelines. You use us for model serving, and we'll go build the pipelines and deliver that data. What they were telling me in this challenge they had was that often what happens is they give the model to the ML engineers, and the ML engineers go find similar data in production. It's not the same, but it's similar, and so they just plug that in as the features. It's a different model at that point, right? You would train a different model on top of that other data, but that doesn't happen, and they just end up with a model that now they have no idea how it's performing. They have no idea whether or not it's meeting the expectations that they had when they tested it, because they're basically applying it on an entirely different data source, right? And that's the kind of thing that can just go away. That problem should no longer exist if you're building on top of a data lake, right? And then show me the model, right? So we go from the data to the model, the training and understanding of it. You can train it yourself. You can train it with AutoML. You can understand your model, dive into things like the SHAP values and understand the feature importance. By the way, if you're not selling the SHAP values to your business, you're making a mistake. I guarantee you that all of your business leaders, if you said to them, hey, I've got a model that predicts X, and then you said, and by the way, it uses these inputs, and I can tell you the order and magnitude of importance of these inputs, right? That's the kind of thing that the business leaders would kill for, right? And so making sure that you're vending some of that information to them, right? Registering and governing your model. Governing, right? At Databricks, that model just apply. I was talking to a very large retailer, and I asked them, I said, hey, how do you prioritize when and where to retrain your models? And they just laughed and said, you think we know where all our models are? Right? And they kind of said, they were like, we have, this team has an Excel sheet with some models, that team has an Excel sheet with some models, right? Not only do we know where the models are in Databricks, they're governed, right? So the people who have access to the data are the only ones who have access to the model unless you go in and change that, right? And that ability to now ensure that you haven't just built a data exfiltration layer in this model is critical, right? So registering and governing your model, reducing the complexity and increasing the transparency of all of this, right? Ending that training serving skew. Again, the number one problem in machine learning, right? Training serving skew. Really getting to a place where that never happens. Now, if I were smarter, I would have probably, or if I could go back and meet with the gentleman who wanted it in 3 hours, I think I could probably say, we haven't gotten it to 3 hours, maybe we've gotten it to half a day or a day. But I've made it so you're not going to screw it up and have to spend 3 weeks on it because you had a massive training and serving skew problem or something. So maybe hopefully I've taken the average down by even more. And then just making it as easy as possible to ship the model and serve it, right? And really easy to go and kind of capture that value that you've created. So before I continue on with the boring stuff, I'm going to have Nick come up and show you some of what we just talked through.
Sweet. Thank you. I'm going to hopefully try to match Craig's energy, but that's a tall order. All right. So, quick background on myself. I actually started my career in the aerospace world, where my job was basically to take data from fleets of deployed jet engines all over the world, train models on it, use those models to run nightly processes that would set alerts, and then my job was every day, go in, open my computer, first check that my replication wasn't broken, then go look at my alerts, see which ones were real, and then go and tell people what they had to go fix. And these were multi-million-dollar planes, engines, so I had to be right. So I wish that I was able to use a platform like Databricks back then, and now kind of with those lessons that I've learned, it's really exciting for me to get to show you kind of like the future of what it looks like. So I'm going to touch a lot of the points that Craig talked about, and I'm going to try to kind of make them real in the product. So first, as Craig said, look, let's be honest, machine learning really does start with the data, right? Databricks is an awesome place to do your data exploration. You could do Python. Our notebooks are multi-language, so whatever you're comfortable with, Scala, R, Python, you can do it here. And SQL. So for me, I spent a whole lot of time in relational databases writing a ton of SQL. You can also do that in Databricks really easily in the same notebook. I'm not going to bore you with a whole bunch of boilerplate code, but your analysis might look something like this, right? Now, this demo is going to follow a churn model. I'm not going to show you how to train the most amazing churn model in the world. That's not really the point, right? The point is to kind of see all of the different surfaces, all of the ways that we're helping people train whatever model you care about and deploy it and be confident that it's going to be kind of production ready. So if you were training a churn model, you might do a quick analysis, kind of look at your data distribution. Let's look at some usage trends, some sample customers. We see that, all right, the churned customers, yep, they're plummeting, their usage has stopped. That's what I would expect. The ones that haven't churned, they're still using everything. All right, my data's kind of looking good. I can start looking at some correlations, maybe marketing engagement. Oh, well, maybe we're engaging a little bit less with these churned customers, but hey, I'm not really sure that I'm seeing like a marketing spend correlation here. So let's go and start taking kind of the next step in the model training process. Once you've kind of figured out a rough picture of your data, generally you start breaking this data out into features. Now, in my world, in my past, this looked like writing some pretty gnarly SQL statements and creating views and kind of layering a bunch of stuff and dealing with staging production databases. I'm giving you a sneak peek into our new feature engineering API. So now what we can do is we can actually define features programmatically in my opinion, a much more legible format. And so you'll see here, the first thing we're doing is we're defining a source table. So just like any other table, for us, we're using Unity Catalog. And we're gonna touch that a little bit further. But we're giving it a primary key. And since we're gonna be building some time series features, we're also gonna tell it what time series column we'd like it to use. Now, important point here, primary keys are crucial for feature tables. And as Craig alluded to, you can use the feature engineering API, but we can use any table that has a primary key as a feature table as well. Now, when we actually define these features, you'll see that we only have to give it a few things. So we're going to give it the source table. We're going to tell it the input column that we want to aggregate, and then the type of aggregate. So it might be an average. It might be a sum, right? We have a couple of different kind of standard aggregates. I'll look back. Generally, if you're creating features, pretty often they're windowed features. And you can also do offsets. So you'll see we're just generating a few of the features we looked at in that exploration. usage intensity, active days, total errors, general features that should help us kind of shed light on if someone's gonna churn. We can also do kind of more advanced things, right? So usage average previous 30 days. We're doing a little offset. So let's say I don't want to know just the last month. I want to know the month before that, right? Very easy, just one more parameter. Then we can just combine all these features, and we can materialize them into a table. Now, we're going to look at that in a second, but I do want to show you one other really cool thing about the feature engineering API. We can use that materialized table in queries just the same as any other table. And something that would have helped me a lot in the past, we can actually compute features on the fly. So if somebody comes up to me and they say, hey, we noticed something really weird happened between March and April of last year, I can super easily pull all the features that I might have used to train that model and very quickly come back with an answer as to, hey, what might have happened here. So that's very useful for me. Now, before I go show you the table, I got a call from the marketing department, and they're like, hey, we have data too. Can you also use ours for features, right? Same thing. If I want to make features off a different table from a different department, exactly the same pattern, very easy. I just define a different source table, and I can do exactly the same kind of structure. So now let's go look at where this ends up. So I'm jumping over here to Unity Catalog. Now, Unity Catalog is kind of our shared governance layer. So you'll see, actually, I'm going to go to the overall catalog here. This is called North Star. This is kind of our mock company. And we have some product and marketing schemas. This is how we kind of collect assets in the same place. So what does that mean? Well, if I go into the product schema, you'll see that we have some tables. You'll notice we have some kind of normal tables here. And then we have this materialized view. Well, this is actually where our customer features ended up. Now you'll see that we do have an enforced primary key. And as Craig said, any table with a primary key we can actually use to pull features. Now, an important thing you'll see on the right here, it says current pipeline update status. That's an interesting choice of words. Now, the reason we say that is because when you use the feature engineering API to create these features and materialize a view, you've not just made some base table that's sitting somewhere, you've created a whole pipeline. So when you use that to train your model and you deploy that model, you're not just deploying the end code. That model knows how to serve those features. Now, why is that important in the grand scheme of things? Let's say you want to deploy a model at 100,000 QPS. That's great. That model, it needs features. Are you going to be able to pull that data in at 100,000 QPS? Or is that model going to be happy at 100,000 QPS and only giving you 5? Because that's the velocity that the data can come in at. We're working to essentially eliminate that. So let's go to what model training looks like off one of these feature tables. Now, I'm going to not show you anything new in the model training world. We're going to use sklearn. So this is kind of the general, we'll call it boilerplate model training routine. But you'll notice at the start we're doing something a little different. Instead of writing some query to pull the training data in, we're again using the feature engineering API. We're saying, hey, look, we've built this feature table, customer features. We want to use these 4 features. Here's our lookup key, and here's the timestamp that we want to use. Then we use that to create a training set. So I did actually, okay, I lied to you a little bit. We are going to write a little SQL. So you'll see here we actually did pull in just the latest status. Basically, when you're creating your training set, usually you do pull a list of labels that you join the features onto. Something very cool about Databricks, you can write something in SQL, for example, like a select star statement like this. In the very next cell, you can go ahead and you can actually query the results of that SQL statement and toss it right into a data frame. If you like Python more than SQL, you don't have to choose anymore, right? So that's what you're seeing going on here. We're going to join our features on to those labels. Now you can see here we've got our features. Our label is churned. And generally, if you're training a model, you'll know there are some columns you're going to want to not include. For example, customer ID and observation date are going to have no impact on a churn model. So you don't want to include those in your training data. Now I'm going to show you some very normal sklearn code that's just training a regression model. Nothing kind of new here. We can, again, look at the feature correlation, so the SHAP values. So you can go and you can start now kind of telling people, hey, look, these are the different kind of signals and how important they are into training this specific model. And then you can deploy it, except, again, I'm going to get a call from the marketing department saying, hey, I don't see my feature on here. What's going on, guys? So I'm going to show you real quick how easy it is to just use another feature. All I have to do, one more feature lookup. We've already defined the table. We've already defined the features. That is the only difference in the code if I want to include a whole nother data source and a whole nother set of features. And now if we train this, and for the interest of time, I've already done it. Boom, we've got our 5 features, and now we can go back to the marketing department and say, hey, I don't know if your marketing spend's doing quite as much as you think it is, but wow, the error rate sure might be. So again, explaining what goes into the model can be very, very useful in kind of changing the business impact of it. Now, let's go see, last thing. So once we have trained this model, we need to log it to Unity Catalog. So why is this important? Well, I'm going to go back to Unity Catalog here. As Craig alluded to, it's our shared governance layer, right? So we have our tables here. You'll see our feature table and the table that we built that off of. But we also have our model here, right? And there's a little sneak peek into the second half of the demo, but you'll see we even have some functions. Now, the real beauty here is that you can assign permissions at the catalog or schema level. So if you have a team of data scientists or data engineers that you need to give access to not just the data, but the model, all the features that were generated, you can just assign them to the schema or the catalog level, and you can now control and easily kind of give people and the right people access to the right things. All right, so now, let's say that, hey, I might not have trained the best churn model. I tried one set of hyperparameters, and that's it. I only tried one regression model. What if I want to just run a sweep of them? That's where you could bring in something like AutoML. So AutoML lets you assign compute. I'm giving it a training data set. I can actually join features. So just like before, we can look at the features that we've defined. It knows which my feature tables are because any table that has an enforced primary key becomes a feature table. It already knows which one to join off of. Now I've got to tell it, here's a timestamp lookup. And now I can go ahead and start AutoML. In the interest of time, I've already done a run. And it will go, and it will sweep hyperparameters, model types, and it will actually train a bunch of different models that you can then look at, decide if you want to use, if they beat your model. In this case, it did, so we're going to use an AutoML model. You can then click and register these models into Unity Catalog as well. And then, once they're in Unity Catalog, I want to show you one other thing. Let's go back to the other catalog here, just for continuity's sake. This is one of my favorite parts. You have model versioning in Unity Catalog, so if you are deploying a whole bunch of models, you can leave your notes, you can kind of alias them. You can serve it from here, which we're going to do in a second, but one of the coolest parts is that if I go to one of these versions, I can click into the lineage. And now, I can actually pull up a graph, and I can see not only what data this model was trained off of, but what else might be trained off of that data. Now, why is that important? Let's say that you start getting that feature drift. Someone calls you up and they say, hey, our model is terrible. I've gotten this call. Hey, I can't find any data for the past 3 days. Oh, why? This lets you very easily trace back to figure out what's skewed and what else that might impact down the line. In my case, for some reason, they started sending us the engine serial numbers backwards. They didn't tell us. And then they yelled at us for not having the data ready. Fortunately, with something like this, you could figure that out really fast, and then you know where else you need to fix things. Now, for the last part of this demo, let's go to the churn model. We can actually serve this model. Now, again, this is kind of part of the magic, right? You've trained it on features. The features are served themselves, right? So now you can serve this model with super high throughput. It'll automatically stand it up behind an API, and it enables a bunch of really cool things. So you can enable usage tracking, so you know what the QPS is and how many people are hitting this. You can enable inference tables. which logs all your inputs and outputs to Delta tables. So if you need to do some offline evaluation later, you can do that really easily. You don't have to set up a whole separate pipeline. And you can enable rate limits. In case you have a very expensive model or you have budget constraints, you can make sure that you don't blow those out of the water. You can also do one really cool thing. You can traffic split. So if I have two different versions of a model, I can actually send half of the data through one, half through the other, all behind the same endpoint. So if I want to do some A/B testing on my actual deployed side, I can do that really easily. And I can track all of that, again, in my inference tables. It will show you which model was hit for the request. All right, so let me show you what a served endpoint looks like. And then, since the model is now served, I'm done, right? Back to you, Craig.
Perfect. Thanks, Nick. You know what? One of the things Nick didn't share with you, but is really exciting, is that not only can we, when we talk about serving the model, we can also serve the features. And if you were at the keynote this morning, you heard about Lakebase and our acquisition of Neon. We've been, as Ali told you, he said, we've had hundreds of customers over the last 6 to 12 months kind of using this capability, testing this capability. The first use case we tested was serving features, right? So today, you can start serving features using Lakebase to kind of have an ultra low latency, both model serving and feature serving together. So, really trying to drive the simplicity of serving these models, right? Trying to make it as easy as possible. We're not going to go through kind of full integration into a CI/CD pipeline because, to be honest, in my experience, no one person's environment looks enough like anyone else's for anyone's CI/CD pipelines to be kind of massively generalizable. I will have a QR code at the end, though, to our big book of MLOps, where you can learn a little bit more about how we recommend integrating with CI/CD if that's a priority for you. Nick talked a little bit about monitoring your model. Listen, monitoring your model is a commodity. Every reasonably good AI platform out there will do model monitoring. The real magic, though, with Databricks is that lineage graph, right? The ability not just to monitor your model, but to monitor your feature tables too, so that when you see your model's not performing the way you expect it to, you can immediately see, hey, it's not working the way I expect it to because feature number 4 is misbehaving, right? You can immediately know what is the blast radius of this problem and really trace it back immediately to the root, instead of having the data scientist and the ML engineer arguing with each other about whose responsibility this is, right? Now, gaining value from your model, right? We've got a serving endpoint up, so we could have an app that's hitting that endpoint or something like that. But we want to talk about the fact that that's just one way of gaining value from your model. The vast majority of machine learning models get batch served, right? And so we're going to talk a little bit more about batch. Nick will come up in a moment and show you batch. Also, man oh man, it wouldn't be a conference today talking about any sort of computer intelligence without mentioning GenAI, right? And so how do we make this available? One of the patterns we see repeatedly is the fact that folks want ML models in their GenAI, right? Oftentimes people will come to me and say, hey, I want to build a model, or I want to build an agent that does this. And I'm like, a recommender system, right? And it's like, okay, we can do that, right? And so really, how can we democratize this access at scale? So with that, I'll have Nick come on up and show a little more of this.
Sweet. All right. Now the fun GenAI stuff. All right. So let's pick back up where I left off a couple minutes ago. I've now served this model. It is behind an endpoint. All right. This is what that served model endpoint looks like. And if you go on the top right, oh no, it's scaled to 0. Let's wake it up. So you'll see, I guess a good time to talk about scaling to 0. So if you have models that aren't constantly being hit, you can actually set it to scale to 0, and it'll let go of the resources while it's kind of not being used. In my world, we had probably a 6 or 7 hour window where we knew just no models were being run. We'd run them mostly in batch. This is kind of save you money. You don't have to use it. You can disable that if you need something that's constantly on. But if you want to use this model serving endpoint, you'll see that we can query it. This is just like a little UI that lets you test it to make sure it's working. Then you can use it through kind of a curl through the web browser. You can have your normal API like you would expect. But where a lot of the magic's going to come in here is that you can also use it in SQL. Now, why is that powerful? I'm going to show you in a second. And scaling from 0, but it's OK. We're going to just go look at this. Using it in SQL really enables a lot of really cool things down the line. So we can run a normal SQL statement against it. Now, you'll see we're just feeding it parameters here. And it'll give us back a probability, right? OK, cool, whatever, right? But now imagine that instead of giving it the inputs, we just join it to the feature tables that we've now served, right? Now, I apologize. I know this looks like a lot of SQL. It's actually not that bad. So we're creating a function called getChurnPrediction. It's just taking one input, the customer ID. What it's doing is it's actually, oh, can I zoom in here? You'll notice that the customer feature tables and the marketing feature tables that we made earlier, we're just hitting them for the latest data for that customer ID. Let's see if I can zoom back out. OK, a little wonky. Now, we're going to create a SQL function for a very specific reason. Now, we're going to create this function in Unity Catalog. So we can query it just like any other SQL function right here. Right, getChurnPrediction, we'll give it the customer ID. It can go and look up all the data. Make sure my endpoint's up. It's back. We should be good. Give it just 1 second. Yep, there you go. We got an answer. Right, we can change this so you know it's real. And now, because we've registered this in the Unity Catalog, we can do some really cool stuff. I want to let this finish just so you guys know this is not fake. There we go. Wow, that's a much higher number. So now, actually, let me go to Unity Catalog first, because that's actually kind of cool. All right, so we're back in our catalog. And now we have this function. Because it's in Unity Catalog and it has that shared governance layer, we can go over to the playground. Now, in the playground, we could ask Claude for, hey, I'm a little worried about customer 48. Can you tell me how likely they are to cancel our service in the next month? Oh, I have no idea who customer 48 is, right? Which is a pretty understandable response. But why don't we fix that? We can actually go to this tools dropdown. We can add tools. And because we've registered our function in Unity Catalog, I can now add the function as a tool in the AI models belt. I can ask it the same question. Except this time, instead of saying, look, I'm going to be honest, I have no idea who customer 48 is, it can actually use these functions to go look up a deterministic answer for your question based on a model that was trained on real data. So now you don't have to worry so much about, oh, this model is just going to hallucinate and make something up. It can actually go call models that you know and you can vet and you know their performance, but you can still get the kind of human interoperability of LLMs. And now I'll wrap it up with one more kind of really cool thing. We have something called Genie. So let's say that you're not ready to build a whole agentic system. You just want to enable some other folks in other departments to use your deterministic model that you've deployed to help them answer questions. You can actually configure Genie to call SQL functions. So I can actually ask Genie, hey, can you segment customers into 4 churn risk buckets and show the average API errors per bucket? Now Genie can go and, using the context that you've given it, using the SQL functions, using that deployed deterministic model, it can actually give you the answer to this question. And in the interest of time, we're just going to, come on. We only have 40 seconds left, Craig. I apologize. We're going to look at the results here. So you can see, hey, look, it can actually do these buckets. And hey, look, the customers that are the most likely to churn, look at that. They have a whole bunch of API errors, right? Maybe we should make sure that our product is as high of quality as we can. So that's how you can take from training a model to all the way to actually using this deterministic model in your AI systems. Now I'll give it back to Craig to close this out.
So looking ahead, the feature store API or the feature store SDK that you saw is new. A lot of obviously this GenAI involvement is new. expect more there, right? How do we make these things easier? How do we make them deeper? I would expect that if you come back this time next year, you may see classical machine learning bricks as a part of the full offering, right? But this idea that we want to just make it easier, regardless of whether or not this is a transformer model or a scikit-learn model, we just want to make it easier to gain value from your data. Please complete your survey. I'm not saying that we need really good reviews, but if you want an ML talk next year, just saying, all right? Like, yeah, and then, stay in touch, build some features, train a model, keep in touch, give us feedback, let us know. Our engineering team working on ML would love to hear from you. They don't hear from enough folks. And lastly, grab the big book of MLOps if you want to learn more about kind of how we think about CI/CD. But really, thank you very much for coming to what is a shared passion, my guess is, among a relatively small community here at the GenAI conference. But great to see ML is still alive, and hope to see you next year. Thanks all.